A pleasant day, everyone. We are the group 10 and today we will be tackling about lighting systems. Now, what is a lighting system anyway? Having searched the web numerous times for a definition of what lighting system is, an exact answer cannot be found. From what we've seen, we have come to a conclusion that lighting system are a group of lights assembled and designed together for a specific function. One type of lighting system is found in the world of gardening, where it is defined as an artificial source of light in order to aid indoor plants in growing. There are many ways one can utilize a lighting system. The first type is the general lighting, where it acts as a replacement for sunlight. This aims to light over the whole area. Next type of lighting system is the task lighting. In task lightings, the designs are more specific to fit a purpose. An example is a desk lamp, which is designed for reading. And lastly, the accent lighting. This type of lighting aims to add ambience to enhance the visual of something such as painting and sculptures. This is usually brighter than general lightings. Now to the root of light systems, the light bulb. Even before Thomas Edison, there had been numerous attempts of creating the perfect light bulb. What made Edison's invention stand out was that first, it had an effective incandescent material. Second, it had a high vacuum. And third, a high resistance that made power distribution from a centralized source economically viable. Year 1879 was when Thomas Edison first showcased his invention to the public. It was the first high-resistance electrical incandescent lamp that had a carbon filament. As it can only last for a few hours, Edison went on and tried various materials to be used as a filament. He was then able to discover that a carbonized bamboo filament could last over 1,200 hours.
Now that we have acquainted ourselves with the background and history of our topic, we may proceed to discussing more contemporary events that are relevant to the subject of light bulbs. In this section of our presentation, we will learn about the impacts of these different types of lights and devices that convert electrical and different sources of energy into this resource that we could hardly see without. Energy consumption rates of different countries, as well as how they approach sustainability as a whole, is a fundamental defining factor of just how long we'll be able to keep up the use of the different types of light bulbs, which we will be talking about in depth later in this video. The type of light bulbs that proliferate or are most abundantly used also determines the amount of energy we, as a society, consume. How wisely we make our choices with respect to these seemingly trivial lighting devices contribute to a significant amount, which translates to millions, if not billions, of dollars worth of money and metric tons of greenhouse gas emissions. Needless to say, our actions can accumulate to undesirably severe consequences, not only in our economy but also to our environment. The statistics that you see on screen right now is no exaggeration. According to the International Dark Sky Association, 120 terawatt hours of energy is consumed by outdoor lighting in the United States alone per annum. That can power the entirety of New York City for 2 whole years. Furthermore, the same source goes on to specify these stupendous statistics as follows. 30% of all outdoor lighting in the US alone is wasted. This is equivalent to $3.3 billion in cost, 21 million tons of carbon dioxide emissions, and we would need to plant 875 million trees to counteract these gases annually. There are, however, other ways to combat this wastage of energy. Some of these are using quality outdoor lights. This can save 60 to 70% of our energy and enormous amounts of money. Secondly, we can use outdoor lighting. Outdoor lighting should also be of the shielded type, so it would be focused to the areas where light is most needed. This would increase the efficiency of these street lamps dramatically compared to their unshielded counterparts. And lastly, we should do what's obvious and turn off or remove any unnecessary indoor lights. Now, let's welcome Jordan to explore more lighting parlance that we need to know.
In this section, we will define the terms that frequently appear when talking about light bulbs. Starting off with illumination, it is a state wherein objects and surfaces receive light that is emanating from a light source. You may notice, for instance, that when we use a flashlight, we illuminate the object or send light to the object in order to see the object in a more clear manner. What? You may notice this when looking at a packaging of a light bulb. Light bulbs need a source of power in order to illuminate. In the context of lights, it is a unit of measurement referring to the energy consumed while powering a certain amount of light. Lumens. It is a measuring unit that confines to the source of light. It aims to record the total light energy emitted from a light bulb. Lux. Relating to lumens, it is defined as a measure of illumination. It is useful in determining the intensity of the light that hits an object. It is stated that a single unit of it is equivalent to the illumination a single lumen provides over the entire area covered in 1 square meter. Light efficiency. The efficiency of a light bulb is taken by observing how much the given energy, electricity, is converted into the resulting energy, which is light. It is not to be confused with efficacy because it merely represents a ratio of the electricity utilized in order to create light. Luminous efficacy. In relation to light efficiency, luminous efficacy represents a measurable quantity of the efficiency. It is measured in lumens per watt, in which the lumens of the bulb is divided by the amount of watts that it consumes. Color rendering index. It details the way that we see objects around us. It is presented as a numerical value that represents the perception of objects under different light conditions. Colors are perceived as most accurate or true to life when it is placed under sunlight. The index measures how close a particular light source ability to replicate the accuracy sunlight offers.
The lights are classified into two types depending on where we install and use them. These are the indoor and outer types of lightings. First, we have the incandescent. Incandescent is the most typical type of bulb which Thomas Edison invented. Incandescent produces light by heating tungsten filament inside the bulb when connected to electricity. However, this type is regarded as inefficient as it releases a lot of heat through the process and wastes more energy. On the other hand, compact fluorescent light bulbs or CFL are more efficient and can replace those incandescent lights as this produces less heat. This works by connecting it to an electricity source which excites the mercury vapor inside the coil and then emits visible lights. Next, we have the light emitting diode or LED. LED works also similar to the two in which a current is connected to produce light. However, no filament is burned out in this type, making it more efficient. This is more expensive but has a longer lifespan compared to incandescent and fluorescent. Similar to how incandescent bulbs produce light, halogen bulbs emit light by running through electricity and burning out the tungsten filament. The difference is that this type contains halogen gas which enables the filament to be reused. This type releases more heat, lasts longer, and is brighter than incandescent lights. Next, the type works again with electricity that transforms metal halide into gas, which drives the whole component to produce visible lights. High pressure sodium and low pressure sodium both produces a large amount of light, which makes them ideal to use as street lights. These are commonly used as street lights that emit yellow to orangish color. This type produces light when a particular pressure is reached. As the name itself, higher pressure for HPS and a lower pressure for LPS are required. Last are the phosphor converted amber or PCA and narrowband amber NBA LED street lamps. These are brand new technologies that are not yet fully commercialized in all markets. They are more efficient as it only requires a little amount of electricity to produce light, and the device is known to have a good color rendition compared to LPS and HPS.
We have just discovered the different types of light bulbs. Let us now shed light to each of their properties and who comes out on top for every category. This will help us decide how to choose our lighting appliances and apparatuses the next time we visit our neighborhood hardware shop. Looking at this comparison table, it isn't immediately visible which of these would be your best bet for saving a buck or two, but we will soon see that some are erratically inefficient and others simply remarkable. Having a quick look at this comparison table, we will immediately notice that the incandescent light appears to be inferior to the rest in terms of their maximum efficacies, which is measured in lumens per watt. Its approximated lumens per watt measurement or efficacy is 10. That the rest are substantially higher than 10, namely 80 for LED, 60 for compact fluorescent light bulbs or CFLs, 20 for halogens, and so on. The next column would be the life in hours. Incandescent lights has a lifespan of 1,000 hours in comparison to 50,000 hours of LED, which is a dramatic difference and a stark contrast between the two. For the third column, we have CRI, which is again the color rendering index. Firstly, for the incandescent light, this would be having a CRI of 100 apparently, which is just above the LED CRI and would be equal to halogen CRI. As for the wattage, it would just be the denominator of our efficacy, which is measured again in lumens per watt. The incandescent light consumes about 40 to 60, LED ranging at about 6 to 9.5, which says a lot about its efficacy. Follows that LED is superior to incandescent lights in terms of efficacy overall. That's why a lot of LED lights had replaced incandescent lights and the less efficient varieties of these light bulbs. Now let us proceed to the diagrams that we have here on screen. In the order of their efficacies, the lowest would be incandescent, preceding halogen, compact fluorescent light, linear fluorescent, the HRD or high pressure sodium, and metal halide. And then at the very top, we have light emitting diodes. As these two colors show, there's a contrast between the three, showing that the incandescent light mostly emits heat much more than light. And then as for LED lights, which is the most commonly used type of light nowadays, it has far less wasted energy that is transmitted in the form of heat, coming at 20%, which is basically the inverse of halogen's ratio. That is why LED lights are far more used and popular nowadays. You've reached the end of our presentation. Congratulations! In this video, we've discussed the following. Number 1. Lighting systems and its types. These were general, task, and accent lighting systems. Secondly, the history of light bulbs focusing around Thomas Alva Edison. Next, we had relevant contemporary issues about energy and sustainability. And then we had what habits and actions we can employ to mitigate the negative effects of these issues. And then we had the definition of terms surrounding lighting and its properties. On the 6th, we had types of lights, that is, indoor and outdoor lights. And lastly, we had a comprehensive table comparing these light bulbs' efficiency or efficacy, lifespan, color rendering index, and wattage. And that has been our presentation about lighting systems. Turn off those unused ones, help save Mother Earth. Until next time, goodbye.